Alrighty then. Let me gonna pause the music I'm playing for a moment, which you all will not be able to hear because I'm listening to it on headphones. For I do not wish to be copyright struck, but I also get bored. So, I am going to switch to the live streaming thing here. That looks to be good. Uh, Alright, I've got a live chat. I've put a comment in there. I'm going to be checking the chat from time to time. This is just a can we figure it out project based on a need a coworker has that they're probably going to build via relays and wires themselves. But for fun, I thought I would lay one out, and maybe if it works out as an actual project, I'll open source it or something. Oh, and bonus content. I'm just reset my cookie clicker, so I'm in the process of getting that last Christmas cookie, so that I can then disable golden cookies and enable the shimmering veil and buy all the upgrades and all that fun stuff. It's one last thing I gotta click on. Anyway, so we're looking at like an 8 relay board with some terminal blocks to connect various loads and grounds to, and some switches so that we can turn the relays on and off. And basically, this is just something you would put in your car, for example, to turn on and off LED bars. He's going to be putting LED bars on his truck. He was going to go camping. He wants a big bar up front for driving, and maybe some side bars from when you're camping, and fun stuff like that. So I thought, hey, that seems like something I could probably build in KiCAD and lay out a PCB, and it will be relatively simple, and hopefully I won't screw it up too much, and uh, try to learn a little bit more about how to do that in KiCAD, because to be honest, I'm not that great. I've messed around with it a bit. The hat used to be the one that did all the PCBs for previous projects, but that situation being what it is, I'm trying to learn how to do it myself. And yeah, this is part of that. So I think I've rambled on long enough now. There appears to be one viewer. I don't think anyone else is super interested, and I can't say I blame them. Uh, so let's see here. The first thing I think we need to do. Darn it! I need those friggin' cookies. We need to make a new project, and we'll call this 8 switched relays. And I like underscores in there. And occasionally I like to spell things correctly. 8 switched relays. Gesundheit, little kitty. My cat just sneezed on my arm. Alright, so we're going to first need a schematic for this. And so I'm going to have to put down some relays and some fuses and some terminals to connect switches to. So now that I'm done rambling my introduction, I'm going to turn the music back on so that my ADHD is a little bit better managed, and I will keep an eye on chat and just kind of work through this and respond when people have questions. Does not show me who's watching. Uh, just that someone is. Huh. All right. Let's see here. So I need to place a symbol. I think that's where I start. Yeah, here we go. Oh, that's right. I've got a DigiKey part number we can put in here, and for the relay base. See if that comes up with anything. That did not work. Why are you not working? Copy. We're getting a weird tab in there. Fun. Relay symbols. Alright. We're going to be using this relay. He wants fused relays. That saves some space on the board. Makes sense. I wonder if this will show up. Yeah, it did not. I'm going to do A91 AC 12 volt DC. A91. Who's it made by? CIT. That's a 90 amp. Oh, no, that's a 30 amp. You know what? For now, I'll just use this. We're going to need 8 of those. I'm pretty sure there's a way to duplicate that. So let's go to here and say there we go. Or maybe I'll just place it over and over again. Oh, we got it recently used. Let's do that then. Two, three, four, five, six, Probably should have drawn out a circuit diagram before I started doing this, but you know, we're just gonna make it up as we go. Make a bunch of mistakes, fix them, learn. Alright, so we have some relays. We're gonna need some fuses. Those have load fuses built into them. We'll need a fuse. One of the things that my coworker wanted specifically was he wanted let's just use fuse. Alright. He wanted to be able to have an individual fuse per switch channel. The product he was looking at had one that ran all eight switch channels, and if there was a problem with the wiring on one of those that caused it to short and blow that relatively small fuse, 5 amp fuse, then none of the switches would work, and it would be a pain to get running again. So the idea was to have a variety of fuses that could then be keyed to each individual switch. I personally not thinking that's the best solution, but it's what the client wanted, right? And you know, I'm no EE. It's not like I know any better. Although I did think about doing a version with Arduino headers and momentary switches. 4, 5, 6. Oh, that's uneven. That's going to annoy me. Alright, I should have the ability to move these things, right? There we go. It looks a little bit better. Alright, so we have switch fuses, we have relays. We're going to need a power in and a power out at some point. Ah, missed it. Need to get my last one there. All right. So we got the fuses, we've got the relays. I'm going to need now power blocks, connectors. So what do we call connectors? Interesting. Audio jacks, barrel jacks. Oh wow, that's a big connector. Well, let's see what the part we found on DigiKey calls itself. A barrier strip. No, just barrel jacks. Hmm. Oh, what can I say? I am definitely not Chris Gamble. Interestingly, if you do want to learn KiCAD in a more professional way, for someone who knows what they're doing, contextual electronics, Chris Gamble, the way to go. But again, as I said, this is going to be me kind of stumbling through this. So let's look at connectors again. We can do, I guess, generic connector block. Oh yeah, we've got them in different sizes, and that's what we want. They're going to be two of these. We'll put one on this side, and we'll put one over here. And we'll see if we can't figure out. All right, we also need a ground somewhere. We need a plus 12 volts. We're going to have that come in, and we're going to have a bunch of grounds at some point. Right, let's put a couple down here for now. We'll do a bunch of grounds later. Still didn't get it. All right. Let me turn the volume down on that. There we go. That's a little better. No comments I see. All right. So I'm going to go back to figuring out what I'm doing here. Uh, let me think of how the. 1 second as I think about how the switches are going to be wired up to these terminals. Gotta load that back in my brain. Uh, we're gonna end up with fewer relays, I think. Or I'm gonna need bigger connectors. Oh no, I can run that through the other side of the. I can run that through the other side. Hmm. We've reached the awkward part of the stream, which we're gonna reach many times, where I kind of go, huh, what the heck was I going to do there? Because this is, again, based on a half-baked conversation at work. Oh yeah, I'll do that after work. I'll just throw that together. It'd be fun. I'll live stream it because I love embarrassing myself. I'm kidding. I have no shame. All right. Yeah. Okay. We'll do it that way. we're going to have alright, so here is going to be connected to voltage. And let's, oops. Let's move this. Let's move these over here for a bit. I think I'm going to move these over here. Again, I have no idea what I'm doing. So this is just me figuring it out. I'm going to wire. Actually, should those be buses? I'll be honest, I'm not sure the difference in the schematic viewer. So let's look that up because if I'm going to be dumb, I might as well learn something. Alright, KiCAD difference between wire and bus. Oh, I see. A bus is a bunch of wires grouped together. So if we wanted to connect, interesting. You know what? If this was more complicated, it would make sense to connect these in a bus and then take those buses to places and break them out. It honestly probably still makes sense to do that. So let's delete that wire. Delete that wire. Let's make some buses. Where am I taking this? Each one needs to go to a relay. Load and switch side. So let's connect that there for now. Oh, that'll work. Bus end. Alright, and let's see if we can figure this out. Alright, so how do we break out individual wires? Oops. Huh. I might need to learn a little bit more about that. Darn it, still not got that. Alright, so let's switch back to the bus versus tutorial. Uh, oh, we need labels. I see. Huh. It might be overcomplicating this to use a bus. Or I might be dumb. Anyone in chat have a suggestion? I might try wires for the beginning and just see what we see. Alright, let's just try wires. Alright, so this is going to be a positive 12 volts that we're going to use to drive our switches commonly through all of them. They're going to go through their own fuse individually. Let's see here. Let's grab. Let's move our power over here. Delete this wire. Darn it. Alright, we'll run this back down here because I'm going to take the we gotta think. Alright, we got 3 per relay. One's going to be load, one's going to be ground, one's going to be switch. So let's put the switch in the middle. And that'll have to be connected to a fuse. So that means this one will be the next one. Which means 2 down. This is the next one. I will try to untangle my spaghetti later. And this will be that'll go there. Alright. And then these will all go to the coils of the relays. So when each switch is going to drive a relay through a fuse. So that needs to go to the coil. So you are going to come there, basically. The switch is going to go from positive off of this bus through the switch, through the fuse, and then to ground. Pretty sure. Again, really should have thought this out, but this is just one of those, I think I can figure that out sort of scenarios. So, you can go there. Oh no, not, you should not be connected. Ah, darn it. Alright, so that goes there. This is gonna come down there. Yeah, so I'll play cookie clicker for a second. Making them gains. So a true story about this game. I hadn't played in a while. I'd put it down for a, I guess a couple of months, 6 months, something like that. Then my sons found it, and they were like, "Hey, have you heard this game?" And I was like, "Yeah, sure." And I pulled it back up, and I was still making just huge amounts of cookies off that last save, and so I decided to keep going. All right. So I can tell now that I'm going to want to move these right here over here somewhere. So let's see here. And these fuses. Let's see if we can't figure out a better way to put things. I wish those wires moved with it. Oh, that would be convenient. There's probably a way to do that, and I don't know it. So, full disclosure. You know what? It doesn't matter which side of the coil you're on. Yes! Alright, finally. We got the last one. Snowflake biscuits, or cookies, alright, so we're done with that. Now, it is time to sacrifice 200 of all my buildings, which absolutely cripples my income, which means it's trivial to turn those on. Now, we're going to, let's see here. We're going to make my, and we're going to double that, so that goes up. We're going to, oh, that's right, we have none of those currently. We're going to come down, come on, here. Oh, actually, let's give ourselves a even number. And we're going to buy as many of these as we can based on our initial amount. We're just going to do 200. And now we're going to start with the upgrades. Every upgrade we can afford. Do, 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 do. Oh, and I need to switch the heck out of Christmas, because if I click on that now, it'll be disastrous. Cannot click on those anymore. Alright, and I need any other holiday as soon as possible. But I'm going to keep wasting my money on upgrades. Oh, it's time to really up the gains. Let's go out of here and into our Pantheon. And let's see here. We want milk. I think we want that there, and then we want that there. Alright, so now we should be making some serious bank. Let's switch holidays and just start investing. This is the Blendster got distracted portion of the game, the design process, which happens more often than we'd like to admit, right? Alright, cannot click this anymore. That would be bad. Bad things will happen. But let's see here. We have all of those. But until we get the upgrade and get the wrinklers going, it's no point spending money on one of the other holidays. $171. All right, so yeah, that is what I was waiting for on that. Let's get back to actual work. Well, work being very loose interpretation. All right, so the fuses can be moved as well. Let's move the fuse. Which side should we put the fuses on? We'll put them up here. Let's delete this wire. Delete that wire. Delete that wire. Let's move the fuse. Alright, let's put the fuses. Oh. Let's put you there. Oh, we can do that. Ah. Wow. Interesting. I'm still going to move them, though. We'll do the drag here in a bit. Because I'm going to be deleting some wires and redoing a bunch of stuff. because again, I am not a professional. I barely know what I'm doing, and that is questionable. But yeah, I think this will work better. And once we have this side laid out, we'll match the other side because we're basically matching these blocks to the output terminals. That's all it is. Yeah. All right. All right. Let's take this fuse. We'll put it right there, and we'll take this fuse, and we'll put it over here. And we'll delete all those, which we no longer need. And let's hook some things up with short little wires. There we go. Now, one side is going to go to 12 volts. So let's hook that side up. The other side is going through the fuse and then to the switches, which we decided were going to be in the middle. So that gives me those. Now, this one is coming down and there. And then this one is coming down and there. Alright, that looks a lot more sane than the earlier attempt. Still no questions in chat. Say hi, let me know you're there. Alright, we need our loads in and out. Those are going to go, oops, from here. Actually, let's take that one up. Alright, so now we have a switched output across 1 and 3, controlled by 2, which is what we had been talking about. So when power goes through 2 from 12 through the switch back to 2, it'll go through this fuse, through the coil, and then, well, actually, I guess the switch will be grounding it. Or is it the other way around? Yeah, no, it's going to be the other way around. So I'm going to have to delete this wire. Those are going to be connected to a ground. So let's do a ground real quick. And we're going to put one right here as well. And then because we don't want this to short out, we're going to delete this wire. Let's go to ground. Alright, because we're getting power through there. I do almost know what I'm maybe doing, possibly. Alright. So now we need to connect the other relays to their load pins. That one's going to go there. There we go. Put that there. This one we're going to take over here and put right there. And then this one, right there. It is still a bit of a rat's nest of wires, but it's way less of a rat's nest than it was going to be previously. Alright, there we go. And now we need to connect this load up. So let's bring you down. Oh, wait a second. Let's see here. I need a 13 connector, not 12 connector. That's what we get for miscounting. Well, let's do this again. Let's do 1 by 13 female. We'll place that there. And then we will there we go. Look at that. It's like I didn't even screw that up. Be our little secret. Alright, so now we can take this down here. All the way there. So now we have some grounded coils that are switched via, with their own fuses per switch, so that if there's a problem, it won't take out all of the switches as a common fuse would. Alright, so now let's do this. Let's drag this over here. Drag this junction. Alright, and let's, yeah, we're going to lay the other side out the same way, except we need to do this. Oh. We need to place another one of these. And I'm going to give myself a little extra room there. I'm going to delete that. Oh, that's not what I wanted to do. I wanted to draw a wire down here, because that will need to be that. Oh, let's save while we're doing this. And I'm distracted, so give me a second to buy some upgrades. Oh yeah, sweet, sweet upgrades. Uh, 171. Oh wow, that's gonna be a lot. That'll take a minute. Hey, 3 concurrent viewers. Say hi in chat, so I know it's an actual human being. I am stumbling my way through the schematic portion of a project. And ask the previous viewers, we do mean stumbling. I need some fuses. There-ish. Or thereabouts. Those are going to go there. About there. We're going to put this over here. Alright. So, let's put that there. And I'm pretty sure we could just drop those straight, yeah, we can drop those straight on there if we want. So let's do that. That'll simplify that just a touch. And we're going to essentially duplicate what we have on this side on the other side. Yeah, alright. So, one goes there. So let's do that. Take you out and down. So that gives us actually that's supposed to go to 2, isn't it? It is. So let's delete that wire. Bring you there. Delete that wire. Because this actually goes to here. And then this to there, and these are going to be wired together, and they're going to then go to ground. So let's place another ground. That's fine. Alright, so let's move these down a touch. Give me just a little more room to move stuff around. Route some wires. What do we have? Why do we have a junction here? There, that's what we want. Where's the hand tool? Alright, so that is connected. We now need to connect that to that. No, what the heck? You go there. So you have a fused switch, and you go right there. Ah, how did we miss that? There we go. So that works. Let's do, oh, let's move this ground. Let's move it, over right there. There we go. That's now grounded. Let's work our way backwards for a bit. That goes there, and then this switch goes there. And once again, we missed the little connector. This one is going to come out to there. Down to there. And you come out. Let's go down here. Right there. Alright, everything is wired up. So we now have two junction connectors that can wire up all of the switches, all of the loads, all of the relays. Hey. Let's see here. Spend some money on some upgrades. Alright, no questions in chat that I can see. Alright, that is not my prettiest work ever. And we could have simplified that 12 volt rail a bit. And, ooh, wait. I think I need to connect that 12 volt to the loads. I think I screwed this up. Because all that power, I suppose we could bring that in separately. But no, we want it to go through the relay. Oh no. This is, did I mention this is only half thought out? Because this is only half thought out. I promise. Alright. The 12 volt needs to go more than just to the switches. It needs to go through these connectors. I connected my relays wrong. I connected them as if they were just switching external loads on and off. But I forgot that he wanted this to also provide power to the external loads. Let me think about that for a second. Because there are a couple of different ways this can be done. Alright, let's pretend we're doing something different with the relays here, and let's remove that wire. That wire. That wire. That wire. And let's instead connect those to ground as well. me think about this for a second. And again, for the new viewers, this is out of a conversation with my coworker over. Wouldn't it be cool to do this? Because he found something that was like $200 online, and I was like, I bet I could design that. Uh, but that was the gist of it. So I've not actually thought this through all the way, which is why we're thinking it through now. Because while that does switch a load on the relay via those connectors, if we wanted to power that load from this, so if this was being used to do, as we were talking about, switch 12 volts, 30 amp 12 volts through the relays from the battery from this system to power LED light bars, this needs to be able to supply that 12 volt 30 amp to the relays. So we're going to want a ground for things. So let's connect this to the ground. And this one to the ground. There we go. So those are... Oh, no, I need to ground that as well. No, I don't need to ground that. I need to ground that side. This side needs to go to 12 volt AC. So these both need to go to... Let's place another power. Or we can just drag them over to... Well, let's do this halfway correct. Maybe. Alright, so that's a 12 volt. That's going to be the same as this 12 volt. I'm going to put this to there. I'm going to connect it correctly. There we go. There we go. So that'll be 12 volts. So we can now provide 12 volts output to that. And then we can provide the ground to the terminals the way we've been providing ground. I mean, it ain't pretty, but yeah, there we go. So now let's fix the other side. And again, if you thought I knew what the hell I'm doing, you surely know I don't now. Let's see, are we done with, yeah. Let's see here. So this side, We want to do the same thing. We want to that goes to output this. We want this one to go to ground now, I think. That's what we did, right? We have highlight networks. No, that's, yeah, here. That ground goes to 3. Alright. So this needs to go to ground instead of there. So let's delete that wire and add it to ground. So this is power switch ground. This needs to come off of here. And we can do that. And we can connect that to ground as well. Power switch ground again. Power switch ground again. Yeah, that'll be simpler. Now these here there we go. Oh, let's not do that. Let's go down a little bit and then over. And let's place ourselves a 12-volt power here. And we're going to do the same thing down here. And now let's clean up some wires. Oops. There we go. Alright, so we got power going to all of our relays now. We have grounds going to our loads through the relays. We have our switched relays. Alright. Let's save again. This is actually correct. This is what we kind of wanted to do. And to simplify things a bit, just for fun, I'm going to delete that wire, delete that wire, delete that wire, delete that wire. Put that power right there. And we'll just do a happy little wire right there. And again, this is ugly, 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 ugly. But now if we highlight our power, we have voltage that will be supplied through the relay that way. We have voltage that will be supplied to the switches on those. Each switch is individually fused. There's no shorts. No connections to power or ground that shouldn't be there. So this will now work. And because I cleaned it up a bit, we can, you know, we have these separate blocks, but they're basically the same thing. One you can see is a bit more organized than the other in terms of how the wires are organized. The next thing I think we need to do is assign footprints to schematics and generate net lists and all that fun stuff. But we've been streaming for, let's see here, over an hour now. And I think we have a decent grasp of what we're doing here. I'm going to take a break and refresh my memory on what the next steps are. I'm going to do what I encourage you all to do, which is go to Contextual Electronics on YouTube and pay attention to Chris Gamble's excellent tutorials on how to do this stuff. And remember, I'm just muddling through, trying to figure it out as I go along. Hope you all enjoyed this, and I will catch you all later. Thank you.